Okay, this problem says a small 1000 kg SUV has a wheelbase of 3 meters. If 60% of its weight rests on the front wheel, how far behind the front wheel is the wagon's center of mass? Okay, so here's the SUV, here's the front wheel, the wheelbase is 3 meters. Alright, this diagram is not that good, but anyway. Here's the center of mass. They tell you the front wheel, 60% of the weight rests on the front wheel, so that means this force is 0.6 mg and this force has to be 0.4 mg. Okay. All right, now here's an extended object, so what we'll have to do is we'll have to do sum of the torques should be equal to 0. Okay. And what we'll do is we'll calculate the torque about this axis. Okay. So we'll calculate it about the rear wheel. It doesn't matter what wheel you calculate it. It doesn't matter actually what point you calculate about. But so this is a convenient point. So mg, this is about the rear wheel. The weight of the car is trying to rotate it clockwise. That will give it a negative torque. And this force is rotating the car counterclockwise. Okay, and these two torques are balancing each other. Okay, clockwise torques are negative, counterclockwise torques are positive. Okay, so let's do 0.6 mg, and the moment arm for this force is 3 meters. Okay, and we'll call this distance x. That's what they're asking you. So 3 meters and minus mg times 3 meters minus x equal to 0. We call this distance x, and so this distance is 3 meters minus x. Okay. All right. mg cancels. Yep. So the weight of the car does not matter as long as the wheelbase is 3 meters, and if the front wheel is bearing 60% of the mass, 60% of the weight, the center of mass will be that far behind this far behind the front wheel. Okay, for every vehicle. Yeah. All right, so we have 1.8 minus 3 plus x equal to 0. X is equal to 1.2 meters. Okay, so the center of mass is 1.2 meters behind the front wheel. Okay, so that's what that means.